Okay, we're going to try to determine if this integral is convergent or divergent. And if it's convergent, what does it converge to? We have the integral of e to the negative 5p from 2 to infinity. The way we do this is with a limit. The limit as t goes to infinity. To the t, e to the negative 5p dp. Now we could go ahead and apply the integral to this. What does that give us? That gives us e to the negative 5p over negative 5. Because when you integrate this, this doesn't change, and then you have to divide by whatever you have in the inside with the integral. That's how it works out. Or you could do u sub if you really wanted to see it for yourself. So now we're not doing plus c, we're doing from 2 to t, and we're taking the limit of that. The limit from t to infinity of this thing, which goes from t to 2. So when something goes from t to 2, you first plug in the upper bound. So we have negative e to negative 5t over 5, and then we subtract, plugging in the lower bound. We subtract, plugging in the lower bound to this thing. That's why we have two negatives here, two minuses. Here we have the 2, and this is over 5 also. So we get negative 10. This becomes, and don't forget, we're taking the limit. The limit as t approaches infinity of this thing. So if you plug in infinity into here, what do you get? Well, this is being taken to a negative power, to a negative exponent, which means that e is in the denominator, and it's going to infinity. So if something is in the denominator and it's going to infinity, you get 0. This entire thing is going to 0. So you have 0 plus, because you got a double negative here, plus e to the negative 10 over 5. You're also taking the limit as t approaches infinity of this, but this, it's just a number. It doesn't even have a t. So this is the answer. This is the answer. So this converges to e to the negative 10 over 5. Or you could put 1 over 5 e to the 10.